Welcome to another free training event from Tigera. Thank you very much for your time. Appreciate you guys, everyone attending, taking some time out of their day to join us and go over some of this, the functionality here that we're about to see here. Today we're going to be talking about Calico Enterprise Multi-Cluster Management. Specifically, we're going to be talking about Federation for Kubernetes, Federated Identity, and Federated Services. But first, for those of you who aren't familiar with Project Calico is a community of developers and engineers that maintain Calico. Calico, it's an open source networking and network security solution for containers, virtual machines, and host-based workloads. The majority, Project Calico is pretty ubiquitous as far as providing connectivity and network security for Kubernetes, but it also has the ability to apply policy and secure workloads running on VMs and bare metal nodes outside of the Kubernetes cluster. We've done a couple of free training events on those topics. So if you're interested in seeing how that works, definitely check out our YouTube channel. All of the events that we do, we record. We will be emailing out the slides and the recording, but you can also just join us on our YouTube channel. If you happen to see a video you like and subscribe and enjoy the content, the free content that we produce. Project Calico, we're located at projectcalico.org or at Project Calico on the Twitter. You can join along and contribute to Calico via our GitHub organization, Project Calico, and you can take a look at the community page and see the best way to contribute. We have a Slack as well, slack.projectcalico.org. A lot of our team tries to hang out and provides free support from time to time as we have a moment throughout the day. So if you have a question, please join us along with several other thousand Kubernetes experts and users across the various channels that we have. We have a pretty active community, a lot of active developers, over 150 contributors and growing. And as I mentioned, Project Calico is pretty much the most widely used CNI for Kubernetes that provides network connectivity and network security. And we are well installed on hundreds of thousands of clusters and well over 1 million nodes at this point. Today, we are going to be talking about multi-cluster management. I've done a couple of other presentations on multi-cluster management. Today is going to be a little bit different. The previous ones were focused on the visibility and troubleshooting aspects that Calico Enterprise provides as far as our multi-cluster management capabilities. And you'll see a little bit of that today. But what we're going to be focused on today is one of the a pretty cool capability that we have. It's called multi-cluster management. It's Federation for Kubernetes. So we're going to get into that in just a moment. Then what we're going to do after we go through some slides is we're going to do a bit of a demo. And I forgot to put the link to the GitHub repo in the slide. So I will toss the link to the GitHub repo into the chat now. And it's going to be a bit of a demo, but it's something that you can easily replicate yourselves in your own environment. Today I'm going to be working in AWS, and we're going to be using 3 or so EKS clusters. Just a disclaimer, when you launch resources into AWS, it costs money. So just be cognizant of that. If you decide to go through this demo on your own, it's going to cost some money for the EKS cluster and the nodes and things. And then at the end, we'll have some time for questions, but feel free to type in, just post questions to the chat as we go along. If you have a question or comment, and then at the end, definitely interested to hear about any ideas that you guys have around real world use cases that you might be thinking about as we go through the Federation for Kubernetes capabilities today. So if you have some light bulb moments and start thinking, oh, I could do this with this functionality, please chime in, let us know. Maybe the next time that we do this, we can add in that particular use case and everyone benefits from your ideas. So let's start off. So what is multi-cluster management? Multi-cluster management, Calico Enterprise Multi-Cluster Management It's a single management plane to scale security across all your clusters. We give you a single pane of glass, a single UI to be able to manage network policy, to be able to manage the continuous compliance, to be able to gain visibility across all of your clusters. And you can use that to troubleshoot, secure, defend, monitor, manage, and scale the security for your Kubernetes clusters across your on-prem environments in a particular cloud or across clouds. Wow. Today, we're going to be focused on one of the other aspects of multi-cluster management. Today, we're going to be at that second bullet point there. That's bold. Federated endpoint identity, services, and policy. Specifically, we're going to be focused on federated endpoint identity and federated services. So that's going to be the content we're going to show today in the demo. Multi-cluster management for Calico Enterprise also, it allows you to centralize the monitoring, the alerting, the authentication, and logging in a central place, a central cluster. So you can have a management cluster, and you can add in fleets of managed clusters and have all the centralized monitoring, the alerting, and centralized logging in a single place. It's another capability and some functionality that comes along with Calico Enterprise Multi-Cluster Management. Today, we're going to be talking about federation for Kubernetes. One second here. And specifically, we're going to be talking about two aspects of federation for Kubernetes. We're going to be talking about, and this is Calico Enterprise Federation for Kubernetes. We're going to be talking about federated endpoint identity and federated services. So a federated endpoint identity, what it does is it allows you, and it allows for the inclusion of remote cluster endpoints to be included in the local cluster policy calculation. So if you have more than one Kubernetes cluster, and you have you have cluster A, B, and C, and you have pods running in A, you have pods running in B, pods running in C. And as long as a few caveats prove to be true, that as far as the pod IPs are routable between those clusters, which is the case when you're using, as you'll see today, in AWS, if you happen to be using the AWS CNI, or if you're in Azure and you're using the Azure CNI, or you happen to be running the Calico CNI and you've enabled connectivity to the network fabric. You'll have connectivity between the pods. Will have routable IP addresses, and you'll be able to have connectivity from cluster to cluster to cluster. And what federated endpoint identity is going to do is going to allow a local cluster, for example, cluster A, to be able to have the endpoint data that is available in cluster B and C, and then be able to create network policy utilizing the endpoint identity, the labels that allow you to select and apply policy. You'll be able to do that across clusters. So you can have you can come up with rules like cluster A is allowed to talk to cluster B, but cluster C is not allowed to talk to cluster A. And more granular policy examples. We have a couple in some of the later slides. And then on top of that, we have federated services. And what federated services do is it extends the standard Kubernetes service and endpoints functionality across clusters. And we'll see how that works in just a moment. Federated endpoint identity. So each cluster in the federation acts as both a local and a remote cluster. If we're talking about three clusters, cluster A, B, C. If cluster A is the local cluster, cluster B and C are the remote clusters. The local clusters, what they do is they retrieve endpoint data from the remote clusters, and the remote clusters allow the local clusters to retrieve that endpoint data. So we join the clusters into a federation, and we're going to do that together in just a moment. So we'll see how that works. And once we've done that, once the clusters are, we have federated endpoint identity configured amongst a set of clusters, we have the ability to apply policy using that endpoint identity. And in here you can see there's an example policy for it. Maybe you want to deny inbound traffic from all pods in a remote cluster, except for those within the same namespace. So you can imagine you have cluster A with a dev namespace, cluster B with a dev namespace, cluster C with a dev namespace or a prod namespace across those clusters. And you want to create a network policy that makes sure that the only communication in that dev namespace are workloads from dev namespaces in external clusters, remote clusters. It's a pretty powerful concept, and we'll see how we build on this as we get going here in just a bit. Federated services, what this does is it extends the standard Kubernetes service and endpoints functionality across clusters. As most of you are probably aware, Kubernetes services, what they do is they provide a well-known IP address and load balancing for pods that are ephemeral, and they maintain the list of endpoints that are that make up that are selected for a particular service. So services behind a service will be a group of pods. And normal Kubernetes services are, they only exist and point to endpoints on their local cluster. As you'll see here in just a little bit, we're going to create federated services, and you'll see how we can extend the services across the set of clusters. This provides cross-cluster service discovery for your local cluster. And one of the interesting points about the way that Calico Enterprise Federated Services implemented, as opposed to some, I believe, like the Kubernetes KubeFed federation, we use the pod IP for the service endpoints in the remote clusters, and because of that, that allows us to apply network policy using the label selectors that select those pods. The packets come in, and we'll see the pod IP addresses. So federated services is actually built on top of the federated endpoint identity. They're independent, but they can be used in conjunction with one another. And federated services is used in conjunction with the federated endpoint identity. It's optional. If you have an alternative service discovery mechanism, you don't have to use federated endpoint identity, or excuse me, federated services. Or maybe you happen to be targeting pods across cluster by pod IPs, and you're not using the services. In that case, you wouldn't have to use federated services either. You could just simply connect directly to the pod IP addresses if those were well-known IPs, or maybe you're doing something like stateful sets or something along those lines. Calico Enterprise Multi-Cluster Management. One of the unique capabilities of Calico Enterprise Multi-Cluster Management is that you can use it across the different clouds. So it's hybrid and multi-cloud. Its capabilities extend into Amazon, Google, Azure, IBM Cloud, whether or not you're using a managed Kubernetes offering or a self-hosted option like a Rancher and OpenShift or upstream Kubernetes. It also works across some of the on-prem environments like Anthos, Outpost, and also bare metal. So we're going to hop into the demo, but before I do that, let me take a look at some of the questions here in the chat. So if you have Istio or other service mesh, you don't need federated identity. So this is kind of Calico Enterprise Federated Identity and Federated Services. Don't make use of Istio service mesh. This is implemented via Calico Enterprise. I'm kind of curious to see as we go through this, those of you who do have experience with service mesh, what your opinions are, and how, because one of the things that, as I started to make use of federated identity and federated services, I found that I could achieve things like high availability, canary deployments and things like that without the complexity of adding into service mesh, or without having to take the performance hit that you take by proxying everything using technologies like Istio. So as we get going here, I'm curious to see what you see. But to answer the question, the federated identity and federated services today are Calico Enterprise capabilities, and we're not utilizing service mesh at all today. All right, so let me grab this and toss this into the chat real quick. I already did. All right. So what we're going to be doing today is we are going to be setting up Calico Enterprise Multi-Cluster Management with Federation for Kubernetes on AWS. And as just kind of a high-level agenda that we're going to be going through here, we're going to be launching an Amazon VPC infrastructure stack into my AWS account, and I'll go over how that is set up here in just a little bit and kind of talk about some of the underlying infrastructure. Then we're going to launch some Amazon EKS stacks into the Amazon VPC infrastructure, also using CloudFormation. We're going to be launching 3 EKS clusters. So you can have as many as you want. Today, I thought 3 would be a good number to show. A cluster A, B, C, keeping along with the mantra that we've been talking about as we go through the slides. Then what we're going to do is we're going to deploy Calico Enterprise on each of the clusters. And then we're going to deploy Calico Enterprise Federation for Kubernetes. And then we're just going to look around. We're going to explore Calico Enterprise Federated Identity and Calico Enterprise Federated Services. So one of the prerequisites that we have is, and in order to observe the Calico Enterprise Federated Identity, we need to have this CLI tool that Tigera provides. It's called Calico Query, Calico Q. And if I was to come over here, let me just open this in another tab. If we come to our docs and you come here, you can see that there's a link here for installing the CLIs. There's 2 CLIs we have. We have Calico Cuddle, and we also have Calico Q. Just click on this real quick. And you can see the instructions are here, how to go about installing that on a particular host. I've got like the cheat code here for those of you who have contacted Tigera. So in order to get up and running with Calico Enterprise, you need a pull secret and you need a license key. And so for those of you who are interested in trying this out after, at the end of the training here today, I'll post up some links to how to get signed up for a trial, or you're welcome to contact us if you wanted to potentially try this in your environment at home or on-prem or something. So in order to complete this demo today, we're going to require having this Calico query tool installed. And I've actually already pre-installed this on one of the Linux nodes that I've got set up to be able to go along with the demo. So the first thing that we need to do is we need to launch an Amazon VPC infrastructure stack into my account using CloudFormation. So the first thing I'm going to do is let's set our default region. I live in Virginia, so we're going to be, I actually live in US East 1. I'm located right here in Data Center Alley in Ashburn, Virginia. So let's come over here and let's just set that. And then what we're going to do is I'm going to quickly deploy this VPC stack, and we're not going to have to wait because I've already deployed it. And so, but what we have here for our base networking environment is we have this is in a single account. It's a single VPC. It's got a 10.0.0/16 IPv4 CIDR. And we have subnets for each availability zone. You can see here, today we're going to be working in the public subnets. I just want to point out that the different subnets we have are 10.0.0/24, 10.0.1/24, 10.0.2/24. So you'll see these IP addresses coming into play in just a moment. We are going to, each EKS cluster is going to have nodes that span across these different availability zones, and they'll have the EKS clusters will be utilizing the Amazon EKS AWS CNI in the clusters for network connectivity. And we're also going to be installing Calico Enterprise to give us the visibility and the network security controls, the ability to apply network security policy to these endpoints. So it'll be a combination of Amazon EKS with the AWS CNI with Calico Enterprise installed. All right, so the next thing we need to do is we need to install some and launch some Amazon EKS stacks into this Amazon VPC that we have just created. We're going to launch 3 of them. And we're going to have a cluster A, a cluster B, and a cluster C. And you can see here that I'm going to name these stacks appropriately. We got Calico Demo, EKS Cluster A, Cluster B, Cluster C. So let's just go through here. We're going to be using Kubernetes 1.16 today. Let's just go ahead, and we're just going to go ahead, and we'll see that I've already deployed these as well, but I'm going to run through this just so you can see that if you were doing this and at home in your own environment, you would come to the same results. We're not going to have to wait the 15 or so minutes per each one of these clusters launching. We only have about an hour, well, half an hour or so left. All right. All right, so now that we have launched our VPC, and now we have 3 clusters, we got 3 EKS clusters. They're all up inside of our AWS account, and the nodes, and each cluster has 2 worker nodes. Now we need to be able to talk to this cluster. So AWS has a CLI command that allows us to update our local kubeconfig with the required credentials to be able to talk to the cluster. And it also allows us to alias each one of the clusters to a well-known name that will make it really easy for us to switch context as we go through and target each cluster to kind of get an idea of what's going on. One of the next things that we need to be able to do, so when you launch EKS, the first thing that you really need to do is to be able to give the worker nodes the ability, the RBAC privileges, to be able to join the cluster. When you start off, you'll see that the nodes will not even appear, and then once you actually apply this AWS auth config map, it will show up and it'll say they're not ready, and then after it will show that they're all ready. So we're just going to run through that again just so we can see that we're doing the same things here, and everything is as it should be. And this should tell us that there should be no changes. All right, good to go. All right, and then next, let's just take a look at the nodes in the cluster and just make sure that they're all ready. So we're going to look at all the nodes in cluster A, then we're going to look at the nodes in cluster B, and we're going to look at nodes in cluster C. Let me do these one at a time so we can see here. So these are the nodes in cluster A. You can see that this has got 10.0.0.249, 10.0.2.180. And what I want you to kind of notice is that the IP addresses are different. Just to see that these are really 3 different EKS clusters, and they have 3 different, each cluster has 2 worker nodes, and they're all different, and they all have different IP addresses, okay? All right, so now what we need to do is to deploy Calico Enterprise on each cluster. And so this deploying Calico Enterprise probably takes like 10 minutes per cluster, maybe. I've already gone through and done that. And I've also joined these to Calico Enterprise. So this is a Calico Enterprise user interface. This is our management UI. You can see that we give you a bunch of visibility across the clusters from like a high level view. You can see all the nodes in this particular cluster. You can see all the endpoints in this particular cluster. This is the management cluster. We give you with the ability to manage policy across for each cluster. And one of the things that, one of the functionalities we have in Calico Enterprise is the ability to manage multiple clusters, multi-cluster management. What I've done is I've added each cluster to my management cluster. So you can see cluster A, B, C. So just like you can see here a few seconds ago, we can see the different nodes here. We got 249, 15, 48. We come back over here, we can see that these are the nodes that make up the management cluster. But if I want, I can quickly just browse by cluster to cluster. You can see 249, you can see 15, we can see C. So this is just kind of, this is the multi-cluster management visibility and troubleshooting aspect of it. You can see this is the user interface that allows you to very easily manage policies across the different clusters. From this cluster A, we come back here to the management cluster. We're not going to be using the UI today. I just wanted to show a little bit about the Calico Enterprise installation and what happens once you're finished completing these steps. The documentation for installing Calico Enterprise on EKS is right here. You can come here to docs.tigera.io, install Calico Enterprise, manage public cloud, EKS, and everything is right here. and as I mentioned, I've already completed that. So we're going to start off on the next step here, which is to deploy Calico Enterprise Federation for Kubernetes. Let me just go ahead and close these down. We'll just look at them one at a time. So I've captured the required steps here inside of this walkthrough and demo. So just to kind of speed things up. But if we come over here and we just look at the docs, they're linked inside of this tutorial. If you come to networking and then you can see Federation for Kubernetes, you can read through an overview and you can get started with the steps. After we install Calico Enterprise, we want to enable the ability for the local clusters to be able to talk to the remote clusters, and we need to enable the remote clusters. They need to have RBAC. They need to allow the other local clusters to be able to contact the API and be able to exchange the endpoint data. This is actually implemented behind the scenes by Felix, and it connects to the remote cluster Kubernetes API, and then it will create the sets of endpoints. So if you're interested in checking out the docs, it's linked off of the main tutorial here. But we're just going to go through and go kind of step through these from cluster A, B, C, and just kind of get going quickly. So what we're going to do is we're going to apply the federation role-based access control and the service account that we use to authenticate to each cluster. And you can see here, I'm just going to kubectl apply the federation remote cluster RBAC with the KDD data store, and I'm going to target cluster A, and then I'm going to do target cluster B, cluster C, and then I'm going to create the service account or a service account for cluster A, cluster B, cluster C. So let's do that now. Well, actually, before that though, let me do this. I wanted to kind of show you Calico Q. So this is right up top here. This is my my Linux box where I've installed the Calico query command line. And I want to quickly just kind of show you what the endpoints look like from using the query tool. So Calico Q or Calico query, it allows you to evaluate Calico policy selectors. One of the selectors is all, and all will grab all the workload endpoints for a particular cluster. Another one is global, and global it will select all the workload endpoints, but also all the host endpoints as well. And you can create, you can use label selectors to target very granularly down to a specific pod or a specific endpoint or workload if you want to, but I want to just grab them all. And so you can see here, what I want you to note is that all of these endpoints that we see here are workload endpoints. And I want you to notice that they're all local. They all start with IP and then the IP address of the node. And then you can come over here and you can see the endpoints that are being matched here. If I change my context to cluster B, and I run the same command again, I evaluate all, you'll see that the endpoints are different. And so what we're doing is we're looking at what are the current workloads running on these individual clusters that are currently, they have not been federated. So we have not enabled federation, and we're about to do that. And I just wanted to kind of show you the before, so when we show you the after, you'll see the difference here. So just make a note that we see these are all endpoints that are local to a specific cluster, in this case, cluster A. All right, let me just we'll leave this here for now. All right, so now let's start to get set up. Let's apply, let me figure out how to use my mouse, and we're going to apply the RBAC configurations for each of these. We can take a look at this in just a second too. It's a pretty simple setup. All right, so we've got the first step done here. See if I can grab this, move this up. All right, and now what we're gonna do is we're gonna add a service account to each one of these clusters, and then selecting it, hold on a second. All right, so now let's create the service accounts. All right, So now we've created RBAC, we've got RBAC, we've got a cluster role binding, a cluster role binding for cluster A, B, and C. And let's take a look at one of these real quick. Let's just look at this so you can see the what we're actually applying to these guys here. You can see what it is. We're just a cluster role and a cluster role binding. And we're allowing the service account that we applied in the second step, these permissions, and this is going to allow the federated identity to for cluster A to authenticate to cluster B and C, and cluster B to A and C, and so forth. So we've we've created the service accounts and we've added the cluster role binding. So now what we need to do is we need to create some kube configs for each cluster. And we are going to cheat with a script that I've produced here. And we can take a look at it. It's pretty simple. Create remote clusters. All right. So what we're going to do here, we're just going to template out some YAML here. We're going to roll through each one of the clusters, cluster A, B, C, and we're going to create a kube config that's going to allow us to authenticate from one cluster to another. So let me just pop this in here. All right, so it's creating the kube config and then it's using the kube config to make sure that it can view the services. So it's just kind of like a test at the end to make sure that my bash scripting hasn't failed us all. All right, and then so next, what we need to do is we need to configure access to the remote clusters. And so we just created that kube config, and what we're gonna do is we're gonna take that and we are going to use that kube config. You can see cluster B and C because this is cluster A. So we're going to create a secret using that kube config for cluster B and C, and then we are going to apply it. This or the remote cluster configuration. I'll show you this in just a second. All right. All right. And then let's do it for cluster B. So you can see that the context here is A. So we're operating on cluster A specifically, and we're adding in the ability to talk to B and C. And then we're going to operate on cluster B, and we're adding in the ability to talk to A and C. And then we're going to operate on cluster C, and we're going to add in the ability to talk to cluster A and B. All right, so let me just go through this really quick. All right. Let's come back over here, cluster C. All right. So now let's explore. Let's explore Calico Enterprise Federated Endpoint Identity. So a moment ago, we saw the before. We saw that as we did the Calico query eval all, that we only saw the local endpoints. Let's take a look now. Let's just copy and paste. Just make sure I haven't botched any. So we're looking at cluster A, and let's query all the endpoints that cluster A sees. Oh, wow, looks like we've got a lot more now. Let's take a look at this. So previously, when we were looking at the endpoints, all the endpoints that we saw started with like IP-10.something, right? And now you can see that we've got endpoints from these other clusters. We're on cluster A, and cluster A now has the ability to query endpoints, and we can see cluster B, and we can see cluster C. So we see when we're on cluster A, we now have the ability to view and observe the workload endpoints on these remote clusters, cluster B and C. You can see B and C, B and C, B and C. Let's change it, the context over to cluster B. And let's do the same query. All right. Now, so we're on cluster B, and so now we can see the local endpoints to cluster B, and we see the remote endpoints to cluster C, cluster A. And let's take a look at the last cluster, cluster C. Let's run the same query. All right. And so you can see it's the same thing. Cluster C, these are the local endpoints for cluster C. These are these endpoints here. If we go to cluster C and we come over here and we look at the endpoints, these are the endpoints that are local to cluster C. And if we also have the ability to view A, and we can see B. And so at this point, we have the ability to apply network policy to cluster A and to apply to restrict inbound and outbound access between communication between cluster A, B, and C, using the same Calico label-based policies that you would use for an individual cluster. All right, and we went over this. You should see output resembling the following, and just as we saw that we had local endpoints, and we also could see the remote cluster endpoints. And so we want you to notice that the local cluster endpoints, along with the remote cluster endpoints, are now available on each cluster. And so we went through and we looked at each cluster A, we looked at cluster B, and you can see that we have now federated identity. So we've accomplished the first part of multi-cluster management, federation for Kubernetes, the federated endpoint identity. So the next thing we want to do is we're going to take a look at Calico Enterprise Federated Services. Before I hop in there, let me take a look and see some of these questions here. So how does NSX and Calico go hand in hand? Calico requires a network underlay, whether that's NSX, whether that's Cisco ACI, whether that's just standard routing and switching. Calico interoperates with any and all of those. So they do work hand in hand. We have many customers who run NSX, Cisco ACI, or they're just doing layer 3 routing and switching. Let me take a look at some of the Q&A. Will the recorded session be shared so we can listen to this again? Absolutely. We record these and we will email these out with the slides, and we also post them to our YouTube channel. So feel free to subscribe and add that little notification bell if you're interested in seeing some more of these. We also do these events again and again and again. So keep an eye out for those. What are the typical use cases of multi-cluster management, specifically from telco grade environments? Is service chaining across clusters done to realize end-to-end service? It definitely can be. So I mean, some of the questions are really good. So what are some real world use cases where you could use this functionality? What I'm kind of showing you today is a tool in the toolbox, and it can satisfy a number of use cases. It can, and as you are obviously like thinking about this, how would I use this? What would I do with this? Keep those ideas coming. I'm going to show you a little bit more as we get into the federated services, but keep those ideas coming. Post them to the chat, and maybe we'll add them into the next demo. So let me just get one more question before I move on here. What are the, let me hop down here at the bottom. What are the Kubernetes managed clusters that Calico supports other than AKS? We support, I think I can't think of one that we don't support. The ones that I use a lot are EKS, AKS, IKS, GKE, pretty much every single one. And what is the use, one last question, what is the use case in this scenario on-prem? The functionality that you're seeing today happens to be done in AWS, but it's equally relevant on-prem, assuming you're using the Calico CNI and you've enabled integration with your routing fabric. Calico has the ability to peer with top-of-rack switches, at which point you can advertise your pod cider and your service cider, and then your pods have routable IP addresses. Much like what you see here with the AWS CNI, that's assigning each pod a routable IP address in the AWS VPC. So let's keep going. Now we want to look at exploring Calico Enterprise Federated Services. So let's take a look at myapp.yaml. I wonder what myapp.yaml, where's my mouse? All right, let's take a look at myapp.yaml. What does this thing do? All right, so myapp.yaml. So what we have here is a pretty simple service and deployment. We're just using, it's just Nginx, and we're gonna expose Nginx via a service to each cluster. I'm calling it my app, and I want you to take notice of a couple of things here. The labels here, label run my app. You're gonna notice that, well, we're going to use the same YAML for every cluster. So of course they're going to be the same, but it's just to point it out, the labels that we're going to apply to the service, when we do federated services, we are going to target the services that we choose to federate via label. So they need to match. And so you can see here that we've got labels run my app. Okay, and so just keep that in mind. And what we're going to do is we're going to expose a cluster IP service of this deployment. All right, so let's see here. You should see a typical cluster IP service that exposes a deployment of my app. And each of them has 2 replicas. Do I have 2 replicas? All right, cool, 2 replicas. All right, so let's go ahead and deploy that. So we're going to deploy that app, that service and that deployment to every one of the clusters. You can see A, B, C. So let's do that. All right. All right, we got them deployed. And then we want to examine each of the cluster's services endpoints. So if I come here and I'm on, let me see my contacts. What are my current contacts? Let's go to cluster A. So kubectl get pods. You can see I've got my app going. I've got my two replicas. And let's do kubectl get svc for services. And we can see that we've got the Kubernetes service and we've got my app is also in here. And what we want to do is let's look at the endpoints. So if we come over here and we just do get endpoints, we do kubectl get endpoints, my app. All right, you can see the endpoints for this service. So when a microservice goes to connect to my app at this IP address, it's going to be load balanced to 10.0.0.173 on port 80 and 10.0.2.147 on port 80. And those happen to be minus O wide IP addresses of these pods. So you can see that this is all localized in just cluster A. So now let's take a look. Let's just go quickly canvas each one of these clusters. Clear this up. All right. You can see each one of these services currently has 2 endpoints. It is the 2 pods that are part of the deployment that was applied to cluster A, cluster B, and cluster C. All right. So notice that each cluster points to 2 endpoints. Now let's deploy the federated service. Let's take a look at the my app federated.yaml. And what we're going to do is we want to notice that there is no spec selector field in the federated service. Instead, there's an annotation with a value that contains a standard Calico Enterprise selector, for example, the same as a Calico Enterprise policy resource. So if you're going to select some endpoints to apply policy, it's the same syntax. And we do that in order to select the services based on the labels. And remember, I mentioned this a moment ago when we were looking at the service, we had that label that said run my app. All right. And so when we look at this my app federated, you're going to see this annotation here. So let's take a look at that. Let's look at this, the files we have in here. My app federated. So you can see this service looks a little bit different than this service. Let's look at the other service. So you can see this service here and has a spec selector here. And then the federated service does not, and that's important. The other important thing is that a couple of things need to be true. The spec selector is not part of the federated service definition. The ports match for the services that you've deployed. And another thing is that the federated services is going to look inside matching namespaces across the clusters. So the clusters have to have the same namespaces across each other. And so you need to be able to have some consistency across these federated clusters. And that's really easy to achieve via things like CI/CD. If you just define your namespaces and your policies and the labels and everything as code in YAML, and you put that inside of a GitHub repo, and you hook up a CI/CD system to just apply it to your fleets of clusters, that's it's a pretty easy way to achieve that. So this is an example of a federated service. You can see it has a name, it has a namespace. We're all going to be inside of the default namespace. All of our services here are all inside of the default namespace. So we have consistency as far as the namespace goes. And then we have that annotation here. We've got the annotation. It's federation.tigera.io/service selector, the selector we're going to use to select the services, which is run equals my app. All right. So now let's deploy that service to each cluster. And we're going to deploy that to cluster A, cluster B, cluster C. All right. I'm going to come back over here. And now we're going to examine each cluster's federated services endpoints. Remember a few seconds ago when we did this, why don't I just do it like this first? A few seconds ago when we did it and we were looking at the non-federated service, we only had 2 endpoints. And so we've got 3 clusters, 2 pods per cluster. So 2 times 3 is 6. And so we have, you can see here, we've got 1, 2, 3, and then 3 more. So 6 endpoints. So I'm looking at the endpoints for cluster A, and let's look at the YAML. Just look at one of these. You can see that this is the endpoints that, so this service is load balancing to pods whose IP addresses are all routable. And you can see the node name. This is a local pod. And then if you come down here a little bit further, you can see that this is actually a remote endpoint. This is on cluster C and this is on cluster B. So when microservices inside cluster A connect to the service, the federated service, that service is going to load balance to not only the pods that are local to its cluster, but also the endpoints that are in cluster B and cluster C. So you have the ability now to have the federation allows you to load balance your microservices across cluster. So think about that for a second. Maybe you have a cluster in different regions. Maybe you have 3 clusters in US East 1A, and you've got they're all in the same availability zone. So you've achieved super low latency, high availability, and then you've got 3 more in B and 3 in C. You could create these different federation scenarios to fulfill different use cases. And there's a lot of different capabilities here around not just high availability or multi-region availability, but also load balancing and also some other functionality that we'll show here just in a moment. But what I want to point out is that this federated service that we have is now load balancing across all 3 clusters. And it's doing that without any of the complexity of a service mesh. We're using, we've done, you just see me cut and paste things here so far. It's not, this is, we also are just using native connectivity that's provided for you via the AWS CNI or the Azure CNI if you happen to be doing this on Azure, or Calico CNI if you're doing this locally. So you don't have to incur any performance degradation as a result of proxying things all over the place. No added latency. So super high performance, super low latency federation across different clusters. So we looked through at this just a second ago, but I just kind of want to go through the docs here that I've prepared. You should see each cluster's federated, my app federated service has endpoints that target pods across all 3 EKS clusters. And it looks like that is the end of the demo, but I want to take a look at some other stuff. What I've got in here, a Ubuntu YAML here. Let's apply that. Apply myself Ubuntu. All right. So let's apply this Ubuntu YAML inside this pod to the default namespace, and let's take a look at it. What cluster am I on currently? We're currently looking at A. All right. So, and let's exec into it. Ubuntu bash. All right. And let's do apt-get update and apt-get install -yes curl. Let's get curl in here. All right. I want to kind of look at some of the service discovery stuff that we talked about. We're gonna make some. We're gonna mess around with our services here. So let me do this. Let me add another. Let me hop out of here at the top. Let's do that. All right. Let's exit out of here. All right. Let's do this. kubectl get pods. So you can see I'm on A. And we've got our Ubuntu pod, and I'm logged into this down here, and we've got my app. And let's look at the services. And we have my app and we have my app federated. So I'm in Ubuntu, and one of the fun things about Kubernetes is it makes it really easy to discover services, and it gives us the DNS short names for them. So I should be able to curl -v. I think I could just even say my app. Let me see, is that, let's see here, my app, HTTP. Am I wrong here? My app, oh, I didn't spell it right. All right, cool. So hold on a second. Let's make this a little bit bigger. Maybe I won't do the minus V yet. All right. So I'm hitting this service, my app, and you can see here, yeah, it's just running and running and running. So I'm on cluster A up at the top, cluster A at the bottom. What I want to do now is let's get the pods. All right. So let's do this. So kubectl scale the deployment my app. Let's scale it down to replicas equals 0. Is that the right syntax? All right, so let's see what happens here. So we have 2 pods, now we've got 1 pod, and now we've got no pods. All right, so now if I try to curl that service, my app, you can see it hangs, and I don't have any connectivity now. But I have a so this local, this service that's not federated, and I'm querying it locally from cluster A. It's trying to connect to its endpoints, which are, we can look at these. Let's kubectl get endpoints for my app. And you see we don't have any, so it's hanging here. We don't have any ability to connect to any of the pods. It doesn't have the ability to to load balance to them. So let's scale this back up. Let's get these pods. All right, we've got them here. And so let's see if this fixes it. All right, we're back in business. I can query that service. So now let's try this again. Let's try to query the federated service. Federated. All right, it's working, it's working, it's working, it's working. Let's run that same test again. Let's scale down the local cluster pods down to 0. We're gonna scale this deployment down to 0. And where a few seconds ago, a minute ago, when we just saw that when we terminated all the pods on cluster A, the service became unavailable. We were no longer able to query the service, and we could see that there was no endpoints. So now we have no pods. And let's see, do we have any endpoints? We have no endpoints, but let's see if we can still query the service. We can. It's just humming right along, right? So let's do this. Let's change the context over to cluster B. And let's do this. Let's get the pods. See, we got 2. Let's go ahead and let's scale this down to 0. All right. And we're on cluster A over here on the bottom. And we're just humming along. Cluster A is just the microservices here are trying to connect to my app, and everything is continuing to work because there are still workloads. There's up on cluster C. There are still endpoints available on cluster C. So if we do kubectl get endpoints, my app, you can see that we still have 2 more. So let's change our context here to cluster C. I'm cheating using my Docker integration here. You can see get pods. All right. Come on, terminate. All right, they're out of here. All right, now let's try it. Now it hangs. So what we just saw was the demonstration of federated identity, federated endpoint identity, and then on top of that, federated services. And you could see how we were able to extend the service across 3 different clusters, 3 different individually managed control planes, and have a service that load balances across those clusters. In our demo environment here, the clusters are all inside the same account and the same VPC, but there's nothing stopping you from putting those clusters in different regions, in different AWS accounts. The only thing that needs to really hold true is that you need to have routed connectivity between those pods, which you can achieve a number of different ways. One, you're just using AWS CNI inside of a VPC. Maybe you are using peered VPCs. Maybe you've hooked up all your VPCs to the transit gateway across accounts. And so there's all kinds of use cases where this can come into play. We've got 1 minute left. I want to make you aware of some upcoming events that we have. August 18th, August 25th. how to secure the network for your GKE cluster. I'm going to be back on the 25th, I believe, for self-service network security for Kubernetes, showing some of the other capabilities of Calico Enterprise, our ability to do staged network policy, our policy recommendation engine, our ability to do just some of the safety guardrails that make it really easy. Well, I don't know, it lends itself better to self-service and sharing the fun of network policy management with ops teams and developers. August 27th, September 1st, September 3rd, taking us down at September 24th. There's just lots of different events. So these are upcoming events. These are all free training. You can sign up for these at tigera.io/events. And if you want to try out some of the capabilities that you saw today, we have Calico Enterprise. If you go to tigera.io/trial, you can sign up for our trial. And if you're interested in taking these for a spin in your environment, on-prem, in the cloud, running through some of these different use cases, the policy auto creation, the preview, the staging, the troubleshooting tools, the security team controls, the compliance reporting that we have, the continuous compliance, the threat defense stuff, we'd be happy to talk to you about that. Feel free to reach out to us in the Slack, send us an email. Thank you very much for your time. I hope you guys found this interesting. And with that, I'm going to just take a look at some of these questions, and then we're going to call it a wrap. Let's see here. Let me see what other questions we got going on here. Adding to my question, so a second. So what is the use case in the scenario on-prem? Yeah, so Calico Enterprise and Calico Open Source, what it does, it allows you to peer with your routing fabric and to advertise the pod and service sider, or specifically the pod sider, and make pods and services first-class citizens on an IP network. So you would be able to connect via ping or SSH to a pod, just like you would a VM or a bare metal node. We would expose that pod network. It would no longer be private and hidden from the world inside of your Kubernetes cluster. We allow you to advertise that, and then at that point you have routable connectivity to your containerized workloads in Kubernetes. And that's advantageous for a number of use cases. Especially if you're dealing on-prem and your workloads have to access things outside of the cluster. So typically Kubernetes clusters will be sitting somewhere in a data center, and there'll be resources beyond that cluster potentially having to traverse firewalls or things like that. If you've got 1,000 nodes in your cluster, your security team, and if you've got a workload that needs to access something beyond that firewall, and there's only like 3 pods, your security team's going to say, like, why should we open up this /16 on the firewall when you only have like 3 IPs that need to access beyond it? If you have routable pod IPs, and you can more granularly control security past network security controls like firewalls outside of the cluster. There's all kinds of things like that. And if you're interested in that kind of stuff, hit us up, let us know. We show you guys a demo and go through some of the use cases of Calico Enterprise. All right, with that, I'm gonna call it a day. Thank you much for your time. We'll email you all out the slides and the videos, and they will all be on our YouTube channel. We have the Calico Tigera YouTube channel. And there's also the Project Calico YouTube channel. You should subscribe to both. Thanks, everybody.